Common Core Geometry, Unit 1, Section 2, Copying and Bisecting Angles. So using a compass and straight edge, copy the given angle here on the given ray. So this is an angle, and this is a ray. A ray is a line that has an endpoint and then an arrow indicating that it's going on forever. So I want to copy this angle here. And so we need our compass, of course. And the first thing we do is we set our pivot at the vertex of the angle we want to copy and just extend really to any length you want. Going maybe about halfway. And It really could be any length. What's important is that you then draw an arc so that your arc crosses both segments that make up your angle. Then keep your compass locked on that same position and go to where you want your new angle to be. And draw that same arc. Like that. So same radius length. And when I refer to this separation of the compass as radius length because really what we're doing is we're creating a circle with that radius. But I often don't draw the whole circle because you don't need to. So what I did was I just set my compass to really any length so it crossed my angle twice. And then using that same length, drew that arc. What I now need to do is measure this angle. So I want to know where, set my compass length to be where it's hitting my angle in those two spots. So in my case here, in this example, I got to close this a little bit. Looks about right. It's hard to be perfect with this tool here. Change colors. And remember, anytime I measure something, I got to do a little slash showing that I measured it. Just like that. And now I'm going to do the same thing, same length, over here, the one spot that I knew it crossed. Make an arc so that they cross. Now that these arcs are crossing, I'm going to make a point there. And then with my line tool, I'm going to simply connect the dots. So right there, I just copied that angle. So real quick, once again, I just pivoted at the vertex here, extended my compass so that it crossed twice, and then that same length drew an arc. Now see how I drew this arc just small enough so that it crossed the angle twice. This one I drew it pretty big because I wasn't sure where it was going to cross. So I want to make it big enough that I know I'm definitely going to go far enough. You don't want to draw the arc too short and then have to extend it later. So I drew it big enough so I knew I would hit it twice. I could have put a point here. So then I measured this separation and just applied that, made a point, and connect the dots. So whatever this angle is now congruent to it. This is a useful construction, copying angles, and it comes up a lot in more complicated constructions. For example, I want to draw a line parallel to line A. Now parallel means that they have the same slope, they will never intersect, they never get closer, they never get further away. I want to get parallel. And we're going to talk a lot more about parallel in another couple of sections. We have dedicated sections to parallel. Properties associated with that, such as angle measurements created and so on. But just for the construction today, I don't want to get too much into that, but what I want to do, the way to do this construction, now there's multiple ways to construct parallel lines, and we'll see that throughout the next couple of days. This honestly is my favorite, and I think this is the best. So really pay attention to this one. Now, first thing we need to do is I need to draw a line like this. This is called a transversal. At least it will be a transversal. A transversal is a line that intersects parallel lines. Now, I don't have those parallel lines yet, but I will. So this is obviously not parallel. They are crossing. But it's going to be a transversal. That's the first thing I need to do. So just draw a transversal line in. And now what I'm going to do is I'm going to copy this angle down here up here. And what I have is if I get these angles to be the same, that's called corresponding angles, and that actually is what parallel lines create. So it's just going to be that same construction I did over on this page. Same thing, copying an angle. This is the angle down here I want to copy. So I'm just going to draw an arc. And then I'm going to come up here and do that same arc. And I'm going to make it big enough because I'm not quite sure where it's going to cross. Just like that. Then I'm going to measure the arc of where it crossed the angle. So I'm going to make it a little smaller again. And I'm going to do the same thing over here. And then where all my arcs cross, I'm going to put points. So I have a point here that was created, a point here that was created. And then I'm going to simply connect my lines, my dots with a line. And what this did is I just produced parallel lines. And now the symbol for parallel lines, we know for like an equilateral triangle, we could do a dash. The symbol for parallel lines is an arrow on both of them. If there's multiple different pairs, you can see if things have the same amount of arrows, like 2 arrows, that means they are parallel. So that's the symbol you can put on the lines to indicate that they're parallel lines. So what I do is I copy the angle of this to here, and if these angles are the same measurement, then they are corresponding angles, that's called, for parallel lines. And we'll get more into the properties of parallel lines in the algebra, but this just, fits real nice with the construction for copying an angle because you could use it to produce parallel lines and a couple other things that we'll see. We'll see this construction come up a lot. Copying an angle is one of the more important ones we have. All right, one more thing in this video is how to bisect an angle. It's, again, another important construction, and it's actually probably one of the easier ones that we have. So to construct the bisector of an angle, all I'm going to do is start off like I'm copying it. Just go to the vertex and draw an arc so that it crosses both pieces. Then, simply what I do is I can keep my compass the same radius, keep it the same length. The two spots the arc crossed, make those points. And then what I want to do is move my compass to those points. And see how my compass is still the same radius length, still the same thing. And just draw arc inside the angle like that. Come to the other point and do the same thing. Where those arcs cross, you make a point. And connect that point to your vertex of the angle. And what that does is it bisects it. It cuts it in half. So that's it. Very short, very simple construction of an angle bisector. Now, first of all, this word bisector, that might be the first time we're using in this class. Bisector means cut in half. Cut in half. So we'll see line bisected. A line bisector, when a line's bisected, it's cut in half. When an angle is bisected, it's cut in half. So hypothetically, if this whole angle was 50 degrees, well, now these angles are 25 and 25. Just made that number up. I have no idea if it is 50 degrees. But that's what a bisector does. Is it cuts it in half, and it produces two congruent angles. Like, let's give this numbers. If we said this is angle A, B, C, and we'll call this point D here. This angle in here would be angle A, B, D. You got to go by 3 angles, A, B, D, and the middle letter is always the vertex of the angle. And this arc, and now we have those slashes to mark line segments, where we could do little arcs to note that angles are congruent. If you see arcs that have double arcs, then those angles are congruent. So keep them single. So angle ABD is congruent to angle CBD. You could also call it DBC, CDB, same thing. I can't just call it angle B because there's a lot of angles at vertex B. So you have to use 3 letters to be more specific. But CBD is the angle. Remember, the middle letter is the most important one. That's your vertex letter. But they are congruent angles. And when an angle is bisected, it produces 2 congruent angles inside of it. All right, that's it for today. We made the 10-minute mark.